Statistical knowledge helps us use the proper methods to collect the data, employ the correct analysis, and effectively present the results. Statistics is a crucial process behind how we make discoveries in science, make decisions based on data, and make predictions. Understanding this, we have come up with this tutorial on advanced statistics. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
So let's get started. Without a further ado, quickly get into why we have gathered today and one of the key concepts that we're going to be looking at when we try to target the session. Now, as we understand, the topic for the day is about medical malpractice and exploratory analytical perspective. So the fundamental question that comes across is, if we are looking at exploratory analytics, are we not looking at any other type of analytics? So to broadly put it into perspective, any analysis, doesn't matter what kind of a problem it is, doesn't matter what kind of industry we are dealing with, doesn't matter what complexity of the problem is, or what is the value that's going to be generated out of the solution that we propose, it always begins with descriptive analysis. And people who are familiar with the background of statistics would know that it all begins with what's happening in the business. So we always tend to define the basics of what, how, where, when, which is like the 5 W's, instead of solving just the why question of it. Because descriptive is just about describing as the process is, so as to understand what all pieces of information we need to dig in deeper. So that's the primary phase, which we call as the descriptive phase, wherein there are two classic type of distinction that happens. Now, descriptive can be exploratory, which is when we are unsure of what we are looking for in the data. Something like what I'm going to do today, which is the case of medical malpractice. When we don't know what data to study, we call it the class of descriptive statistics, or we call it the class of descriptive type of research under the research design setup. But if we are aware as to what we are looking for, the descriptive tends to move towards the diagnostic side of it, which is we know what kind of parameters, what kind of variables would have an impact on my target variable. Just to cite you a very simple example. We all are familiar with the term called as customer churn. Now, when we say that customers are leaving or they are no longer participating or engaging with the organization, we call it customer churn. Now, there are several factors which determine customer churn. But when we specifically look at a problem for an e-commerce industry, we know that there are certain important variables that we kind of analyze to predict the possibility of a churn of a customer. So something like the demographic details of the customer, something like the last engagement duration of the customer with the organization, the number of times the engagement has happened, what is the transaction value, what has been the kind of uh, loyalty with the customer. So over a period of time, how long the customer has engaged with us. These become very critical parameters. And that's where we move a little away from exploratory to be a more descriptive in a form of diagnosing what are the variables that we have to study and why they are impacting. And that's a gradual progression from descriptive to a diagnostic kind of a scenario, wherein we try to analyze the root cause and we try to dig in deeper to uh, completely separate out all the other parameters which are not playing a key role in predicting or in diagnosing the real problem. This is very similar to diagnosing in a real medical terminology as well. Now, we all get into the field of data science, machine learning, directly jumping onto the area of predictive analytics because we are all excited about the fact that we can predict something, we can forecast something for the future. Now that's where we have to actually distinguish, and I would give a very flat percentage in terms of understanding that in my experience over the last 10 years and overall 15 years of experience with data, 70 to 72% of the problem gets solved by just describing it correctly. So the descriptive analytics, which is very, very basic analytics of the data, can solve 70% of my problem. Let's put it in both the ways. The remaining 10% is handled by diagnostic. Now, the the overall out of 100%, the 20% is something that has evolved over a period of time now with the introduction of huge amount of data, technology, the different kind of algorithms, the kind of models that have come up, the kind of open source availability. But still, the pie of predictive and prescriptive is still lower as compared to the descriptive and diagnostic. But that doesn't mean that the value is any lesser. So if you look at the graph, you will understand that as we go from descriptive to prescriptive, it's not just the increase in complexity that happens, it's also the increase in value that takes place. So even if you're solving 10% of your problem using predictive and prescriptive, the amount of contribution that you make to the business is humongous. That's why we kind of target towards achieving predictive and prescriptive capabilities. Wherein the idea is we use historical data patterns to predict specific future outcomes. Now, it's not like a black box. It's not like a what you call it's not like some kind of a magic which takes place. It's a very structured approach of uh, drilling in the data to go to the next level of prediction. Idea is, can we identify the right set of features and can we identify the right set of target variable that we have to consider when we are looking at doing any level of predictions. Finally, the prescriptive is the one which is about the recommendation. Now, this is where, even if you look at it from a perspective of a career, when you start your career, somebody who is as fresh to data science and machine learning as you are, or some of you must be experienced candidates as well, you can fit yourself into each of these roles. So you start from descriptive, which is where most of the business analysis of the data analytics job, most of the data science jobs are primarily starting from, you do a lot of descriptive, you do a lot of dashboarding, you do a lot of business intelligence, you do a lot of data exploration, you do a lot of data processing, data crunching, data wrangling. All these terms you will hear will come under the fall of descriptive. From there, you go to the diagnostic. And as you move up the ladder in the organizations, you tend to go towards prescriptive, which is about recommending strategies, recommending, let's say, steps to the organization as to what they should do based on the problem at hand and helping them. It's like a hand holding process of going along with them in the journey of prescribing as to what data can actually produce. And there are numerous examples as we go forward, we'll talk about that too. Now, so today's question is about descriptive statistics. It's about the exploratory part of the descriptive statistics. So what we do as a first step in data analytics is we do the descriptive part of it. How do we go about it? We summarize the data as much as possible. And when we say descriptive, these are four key pillars, or what I call out of the pie. I have to give equal weightage to what we say as central tendencies and what we say as measures of central or measures of variation. Now, frequency is a simple grouping exercise where we kind of understand which variables, which of the parameters, which of my features are playing more important role. We give a count to them. And then from there, we go to averages, which is the central tendency. From averages, we tend to look at how individual observations kind of vary from the central tendency. And finally, where exactly is my data residing? So we look at what we call as quartiles, deciles, percentiles. We make use of both the central tendency and the variation side by side. And today in this session, I'm going to discuss about all these four, a lot more, but from a very different perspective of solving a problem. I'm sure you would have seen, people who have done any basic statistics course would have seen measures of frequency, central tendency, variation, and position. But interestingly, you would have observed that doesn't matter which level of statistics you're studying, the first unit always comes across as a measures of central tendency, dispersion, because that's where the basics of analysis start from. So what I was suggesting in terms of descriptive statistics is the first step toward any analysis is to summarize the data. And when we say summarizing it, you tend to talk about the frequency of your variable. So what are the counts of different set of, let's say, parameter values? What are the averages in the data? So when we are considering any specific level of analysis to be done, we always talk in terms of averages because of the size of the data and the complexity of the problem that we are dealing with. Moving from central tendencies, which is the averages, we then dump into the variation of the data from the central tendencies to see how far or how good is the spread of the data. And finally, we club the two. We club the central tendency with the variation to create what is called measures of position. So we start to study how is 25% of my data behaving? What is the quartile of my data? What are the deciles and the percentiles in my data? So which is slicing and dicing and getting deeper into the data set. So an entire descriptive analysis comprises of these four subunits, or what we call as a subset of any descriptive analysis. Doesn't matter what is the problem level you're dealing with. This is something that you will always and always invariably do. But it's just like that. We don't even realize that we're doing it. It's just so natural that we start with descriptive analysis all the time. Now, naturally, the next question comes across is, why is it so important to do exploratory analysis? What is it about the organizations? What is it about the problems? What is it about the situations or the processes that exploratory analysis becomes imperative for us to do? Now, there are certain typical challenges that organizations face. Uh, there is a complexity of multiple data sources. There is a complexity of lack of effective ways to um, to understand the relevant data. There, there, there are multiple times their data does not connect so that they can kind of generate a complete picture of the processes. They come kind of lack the understanding about their customer behavior because they haven't put the right set of variable about the customer behavior across the right variables that they can analyze better. They don't know how the trend is changing. They don't know what is the complete 360 view of their customer or the processes dealt internally, which could be a manufacturing process, which could be an insurance service process, which could be a financial process. It could be as simple as a P2P process, where in the procure to payment process, we have to analyze each and every step from the generating the PR, from getting the invoices, getting the contracts, generating final PO. So all the steps, we don't know how all these, uh, let's say, stages can be put together using data. And on top of it, organizations do not know what metrics we should consider to just monitor the performance of these processes. They have no idea as to uh, what are the specific variable and their relationships that we should kind of generate specific metrics that would help me keep a track of the process. I'll give you a very, very simple example. Think about dashboards like in a car. Imagine you driving a car without an RPM indicator or without an odometer wherein we don't see the speed. Imagine it driving without the indication for your turning right and left. You would say we can always do that. There is no need to see the speed. We can always drive the considering, let's say, the lanes that we are in, or considering that what is the safer zone where I can personally draw in and drive within that. But the question comes across is, how would you standardize it? Now, there are so many other things that are happening in a car. Why a dashboard only talks about RPM and odometer? And let me give you a very interesting analogy here. Imagine driving a car without the fuel indication. Can you even think about imagining driving a car without a fuel indication? Now, parallel is the thing. You can compare it with driving a business without the monitoring of the performance of the business. Now, this is where visualizations, this is where exploratory analysis, this is where descriptive analysis, this is where standardizing of your data to generate greater insights by defining those metrics plays absolutely the critical role. So, in the last 10 years, what organizations have basically been able to find out is if we are unable to put the right metrics on top of our processes, we will never be able to improve them. That's why you see a sudden jump into the area of data analytics. Because now imagine any steps in a business is connected to a process. So if you're analyzing any process, how would you do that? You would have to create the right metrics by exploring the data with which the process is connected with. And finally, define those metrics which can help you monitor those particular kind of processes better. Not only better, they can help you improve as well, as we're going to see as we talk about the case that we do. So what do we do? What do we do when we talk about the exploratory analysis? We understand we have these typical challenges. We then start with standardizing the data so that everyone who's making use of the data in the organization has an access to called as a single source of truth. So that's why concepts of ERPs, the SAPs, the databases, all these evolved during the 90s because they were trying to structure the data. More importantly, it is now required if we are trying to build on top of that data an application layer of analytics. That's where we come in as the data science or the data analytics people. Now, under data processing, we not only look at standardization and cleansing, we also look at identification of the missing information. We do transformation of our variables. We do some outlier analysis, which I'm going to show you today as well. Now, with these, we then define what we call as the KPIs or the key performance indicators. Now, these key performance indicators are nothing but the metrics that I was referring to. So the metrics are something like the dashboard of the car that I mentioned about. So we want RPM, we want odometer, we want the fuel to be visualized there. We want to see the battery indicator. We want to see any kind of customized metric that we want to put it in a car. All those kind of KPIs are then put in here. So something like I'll give you an example in terms of, let's say, inventory management so that everyone can relate to it. Now, for an inventory management process, the KPIs perhaps could be we want to measure the inventory turnover ratio. We want to measure the my stock out time. I want to measure my lead time over a period of time. I want to measure the economic quantity that I've been ordering over a period of time. I want to measure the cost of holding a particular SKU over a period of time. So whatever data point that is readily available to me, we would try to generate metrics on top of that to see if the information is made available to me at the right time. Am I enabling my team members to take the decisions in time? That's the beauty of defining the right set of KPIs. And they are completely open. Means every different process that you think about, you can define newer and newer KPIs every time you analyze it. That's the idea about defining the KPIs. And finally, the outcome is that you're able to enhance your monitoring, you're able to efficiently analyze the trend and pattern analysis, you are able to dig in deeper to slice and dice the data to come up with insights which were not readily available. And finally, you get a 360-degree overview of the entire decision-making process. So that's the key why we chose the session to actually have exploratory analysis as the key component. We can talk about predictive prescriptive diagnostic as well, but that's the idea. Now, moving on to the case study, because I would want to spend some time on the live working on the data as well, on the scripts. So I'll give you a context as far as this particular case study is concerned. Now, this case study, as the title suggests, is about medical malpractice. And if any of you is from an insurance sector, primarily from a medical insurance sector, would kind of be, I'm sure, be aware of such kind of malpractices being uh, happening more nations, because insurance still in countries like ours is very at an infant stage. Not of It's not a mandatory affair, but countries like US, UK, Europe, and primarily most part of it, Canada, Australia, New Zealand. So uh, the insurance is the prerequisite for you to get any kind of a medical treatment. So that goes without saying. Now, with this kind of facility, I would say, comes malpractices. Now, if you just look at the left side of what are the some kind of analysis that has already been done historically, which is close to 2.4% of annual healthcare spending in US alone goes under medical malpractice. That's $55.6 billion in a year. Huge numbers. So we are talking about uh, close to a Reliance, let's say, turnover in a year, or the net worth, we call it in that way. We are talking about huge malpractice amount. Now, there are over 7,000 insurance companies, which receives close to about $1 trillion of insurance premium annually, and they are responsible for uh, they're responsible for paying out the right claimants the right amount at the right time. So they have a very simple objective to be achieved. The idea is how to identify which of those claims are not as uh, they are claiming them to be. So, how many of those claims are actually fraudulent? That's the objective. That's the idea about the case that we are discussing today. Now, if you look at from the pain point perspective, when they go into the study to understand uh, how are they basically being cheated, or what are the variety of situations where claimants actually start to make use of the system against the insurance companies. So these are certain pain points. So what happens is high variety of fraud patterns and relatively inadequate ratio known frauds in typical samples. So what happens? The insurance company, once they pay out the amount, they would study the patterns on the historical data. Now, the fraud is such that it varies completely from each other. So every transaction or every claim that is processed in the system is very different from another because of the medical, let's say, emergencies in the real life. So to identify these frauds on such a complex variety of uh, medical severities or medical emergencies or medical scenarios, it's very difficult to kind of find a pattern. Now, if you are looking at from an analytics perspective, if there is no pattern, it becomes the biggest challenge. Secondly, there is a range of activities which are not considered proper that claimants create. So they would create a situation that isn't covered under insurance. So something like a drink and driving or something like an illegal activity. So they would create a kind of a situation so as to claim the amount, which is practically not to be paid for. Now, the third challenge is obviously like a judicial system. They cannot interpret the actual context of the incident. They are only perceiving it based on the documentation, based on the report that has been submitted to them via the medical or via a legal channel. So both the scenarios may be corrupted. That's the idea. And finally, how to know the true impact of the incident. So claimant might be increasing the estimates of the loss. So they might be claiming for unrelated kind of diseases or problems to increase the kind of a medical care. So how how to identify that? Now these are kind of challenges that the insurance companies across the globe face. So very recently, just to take a couple of seconds, we did a project with a Gurgaon-based company who have set up a machine learning solution specifically for medical malpractice claims. I will give you the name of the organization because it's quite a startup. It's called Perceptivity, and they are into the business of finding out these insurance claims using machine learning. Please go out and check as to how they are doing it. This case is very relevant to what this company is actually doing. Now, we, along with them, we actually did a proof of concept for a very large UAE-based insurance company. In fact, it's the largest UAE-based insurance company, and they could not believe that they can actually reduce their 10 million worth of insurance claim frauds to close to a 2 million, from a 10 million to a 2 million. Can you imagine the amount of value that the process can actually bring in? That's what the whole idea of doing such an analysis is. And mind you, The machine learning part of the tool comes very later. It's the basic part of the descriptive analysis that is happening in the tool as well. And once you review that, I think that will help you understand this context better. So what is the case asking us to do? The case is asking us very specific things. It wants us to develop a kind of a better understanding of the claims paid out. So we must dig in deeper for identifying what are the different kind of situations, what are the medical malpractice lawsuits that perhaps are happening that we are unable to identify. Now, how do we do it? It's completely up to us. Now, in our case, as we discussed today, I'm only sharing the exploratory data analytics part of it. There is no doubt that we can go on to the stage of diagnostic, inferential, which is the predictive and the prescriptive part of it. There is no denying that fact. But to keep the focus for today's session, we are taking up the descriptive and the graphical analysis. And finally, the objective is to come up with recommendation. What kind of changes we should bring in the claim settlement process? Now that's the layer of prescription that we brought in, directly moving from descriptive to prescriptive, because we can recommend strategies. Though they will want to do further analysis before going ahead and applying those strategies. But yes, so that's the level that we would like to reach using the live streaming data. So live streaming data means you file a claim online as a customer of an insurance company either rejects or accepts or partially rejects your claim. These are decisions which are taken in hours. Now, with this live, let's say, decision making, we can actually do a kind of a broad based assessment as well. Is the overall objective of the case that we are discussing. Now, how do we go about it? This was the process or the approach that we kind of followed. We first of all start with identifying the relevant vectors or the features, collect the data, whatever will be the sample data that we kind of analyze on the basis of that. Understand it. This is where the description part comes in. Understanding means we look out for any kind of missing information. We look out for what sort of variables we are trying to analyze, how. We understand the type of variable. So simple uh, business statistics kind of work that we do. We then jump on to the analysis part of it, which is the descriptive analysis, which is the graphical plot, which is the summarizing of the data, which is about center tendencies, dispersions, positions, frequencies. All that happens under the analysis section. And finally, we come up to the recommendation section. Now, I would have loved to discuss this in a way that there are other possibilities of the data point as well, because when the team sits to come up with different kind of variables, there is no dearth of the data that is made available to insurance companies by the claim or by the customers, because the entire demography, the entire details of the medical history, the entire details of the medical history transactions is made available to insurance companies before they actually set up their premiums to the customers. Our question was what parameters to make use of or what factors to make use of in order to do the kind of uh, diagnostics or then the kind of analysis that we wanted to do. So what I was saying is in regards to the data characteristics, those were the key parameters that we were supposed to handle. The the sum of the listed variables in front of you, which is highlighted in green, can always be debated, right? These are not the parameters which are the only parameters to be analyzed. But the idea is these were the key parameters which could give us an indication of what different types of claims we are dealing with and how these claims are kind of connected to generate some patterns. So, variable like an amount, which is like a very basic, how much is the claim amount or the payment that has been made in dollars? What is the level of severity of the disease? So we kind of converted that into a scale from 1 to 9, which is a very ordinal kind of a scale. One meant, which is like a very simple, or let's say lower on the medical ground, which is an emotional trauma. And finally, on the highest side being the death as the 9. Age of the claimant in years. So we always look at age as a very important variable as far as historical patterns and any kind of classification to be done. Whether there was a representative in terms of a private attorney or not. And this becomes very critical because this is where the business understanding comes in. So there are a lot of claims which are actually filed via a private attorney. So that is to be analyzed in the data. What is the marital status of the claimant? what specialty of the doctor that the customer dealt with. So the disease specialty kind of the physician. Then what type of insurance do they have? Do they have like a public? Do they have a private? Do they have any unknown kind of an insurance? Do they not have an insurance at all? What is the gender? Now we moved on to the level of analyzing it in a way that we can look at what are the types of these variables so that we can analyze them accordingly. Now, the idea is elaborate them as much as possible to get much more details out of the data. So I'll stop by sharing my deck here and rather move between the deck and my notebook to give you a kind of a snapshot about how it all looked like when we started to analyze the data. And in fact, a quick look at the data might also not. So I think my Excel is made available to do, right? So you can simply have a look at this, which is I'll just zoom this in a bit. So this is the data that we are dealing with. Yeah. So we have amount of each of the claims. So the row items represent the each claim amount or the each claim transaction, and then the column represents the variables under consideration. Now, what I'm using currently is a Jupyter notebook. I'm hoping most of you are familiar with it, but if not, it's just a quick what we call as a development environment for making use of multiple type of scripting languages. We can either use R, Python. You want to do Spark, Scala. You can even go on to the level of making use of any advanced programming language as well. Right now, I'm making use of Python, and the idea is how, in a very simplified manner, I can achieve the objective of the medical malpractice case. Now, my objective for discussing the script is not the script itself, but the outcome of the script. So I would rather not dig in deeper into how am I doing it, but what is the outcome of it. Now, what we look at in the first log, these are nothing but my libraries. What are Python packages, which are readily available in Python to perform any kind of analytics. These are very basic NumPy and Pandas to do the basic mathematical and statistics work versus creating the data frames, which is where the data processing actually takes place. The rest of the all is for the descriptive analysis. It's for the kind of analysis that we want to do on the set of data. If we were using any machine learning or any advanced level of environment, we would have imported those kind of packages. Once we are done with importing the relevant libraries, let me just run it parallelly so that we know there is no problem at the end. So it has been successfully run. That's why it moved here. We then go on to actually read our data. Now, the data that you see here is the data that I just quickly showed it to you. I'm just reading it once. I just don't want any kind of error to actually come up. So you see the star that is coming up. So the process is still on. We would wait for it to show the data head. There you see. So a snapshot of the data is made available to us, which is nothing but you can see in regards to that we have opened the Excel in the backend of the Jupyter Notebook. So this is what data frames are meant to do. So you see this PD, which is nothing but how we are making use of the pandas library. So that's what the idea is. So this is exactly the way the data is available in the CSV format. We are kind of now uploading it in the pandas environment or in the Python environment. As I mentioned, the first and the foremost, the very basic steps in after we read the data is to identify for any kind of missing values. So any kind of not applicable values, any kind of values which might not fit into the data that we are looking at. So what the idea is, we have created the data frame, and we want to see what percentage of these columns have a not applicable or a missing value in it. So the command that you see here primarily talks about to look into the columns where the data columns is stored and find out these columns for missing values. So we are denoting the is an A bracket for kind of identifying those places where we don't have a missing value. So although the result is already made available here, you can see that the percentage column in front of each of the column names is 0, which is nothing but saying it in simple words that none of those columns have a missing value in it. But in reality, in your data case, you might have to deal with the missing values. And there are several ways of imputing your data, which means how you can fill out those missing values. So there comes the first analysis that we wanted to perform. So we went on to first of all describe, uh, and more importantly, before describing on that, I would rather, as a discussion point, and also as a as an ideology or a step-by-step process that you can follow, how to begin with the first step, right? So you have imported the library, you have checked for missing values. How to start with analysis, right? So the fundamental way of analysis that we kind of follow starts with describing each critical column. So we do what is called as a univariate analysis. So we analyze each column one by one and try to see whether there is a story that is coming out of each of those variables. And once we have done the univariate analysis, we then go on bivariate and multivariate kind of analysis, which means once we have understood that amount, gender, severity, how they are behaving, we then try to put two variables together. So how is amount with respect to gender? How is amount with respect to severity? How is amount with respect to the speciality of the physician? All those kind of decisions are taken. So what I'm starting with is we plot the amount as the figure, as the variable, and see what is the variation like. Now, we have made use of box plot. There are several ways to plot the data that you are interested in. You can plot a histogram of the amount. You can think about in terms of what all statistical ways that you can apply on a continuous variable to put it on a graph. Be very particular about the theory that you're applying in the back end. We are dealing with a continuous variable. We can't just put a what you call a line graph to represent amount, because we don't have what is called as an over of time period, because that's the time period sense of analysis that we tend to do. Now, why we did box plot is a question that I can, of course, take up after the session is over. But the idea is we were trying to find out outliers. We were trying to find out where is the maximum concentration of my data. Now, if you look at the graph, so let me run it in front of you so that you can have a better look. So I'm assuming that we know how to read a box plot, but the idea is if you look at the amount on the x-axis, it goes till about 8,000, 800,000 to about a million. So if I look at these spikes and if I look at the box, which is also called the box in the viscous plot, the box basically represents what I call it as my first level of layer of my quartile. So this is my Q1, this is my Q3, and within the line that you see this, the black line that you see in between the blue box is my median, which is the Q2. So what we only witness from here is my median is close to Q1. There is a big difference between Q2 to Q3, which means the median and the third quartile are quite a farther away. What does this mean? So the question starts to rise, what is it that is happening here? What are the kind of questions that you raise to analyze and dig in deeper is the job of a practitioner. So once you plot a graph, the job doesn't end here. You just don't have to pick this graph and paste it somewhere for somebody else to decide on. It's your job to dig in deeper from here and find out what do we need to do from here. Now, if the same thing I look at in terms of data, you see the dispersion of the data here. So majority of the data lies right at the beginning between, let's say, 200,000 to a 400,000 range. This is some of the extreme values. what in other words is called as the outlier value. The other way to plot my amount, which is by plotting the histogram. Now you see from here, the skewness is very distinctly visible, or what we call as the outliers in the data are very, very clearly visible, because most of my sample that I'm dealing with from the data lies in the range of 0 to 20,000. Sorry, 0 to 200,000. The majority of my data falls below 200,000, and only few of the claims are coming to on the higher side. Now it has started to create a picture in my mind that there are certain claims where the claim amounts are pretty huge. I need to dig in deeper into that. Then that's the first question that comes into the mind of any person who's analyzing it. So we park it aside. We now know that our data on the amount variable is very, very skewed, and we have to be very, very focused upon how we need to understand that skewness better. Now, post we have done the amount, we start to look at the other parameters as well. How is my age distributed? Now, as far as the plot is concerned, you can see in front of you, it's very close to being symmetrical around the average value, which perhaps looks like 40, though you can summarize and calculate the average value separately as well. But right now, what we see as a description in front of us gives a clear indication that age is not something which is not symmetrically distributed, which in the case of our context simply means that people from all age groups largely are applying for a similar number of claims. So large number of claims are coming between people of the age 30 to 50, but otherwise the people who are below 30 and people who are above 50, the count or the number of claims that are coming in are very much similar in terms of their count. We then wanted to study whether the data is also symmetrical in terms of the severity of disease, or there are certain diseases or there are certain levels of severity diseases which are being claimed for more. Now, very interestingly here, if you just look at this, you see 3. Now, if you recall, I mentioned about the severity level from 1 to 9. 1 being a very low level of severity, which is an emotional trauma. 9 means death. Now, from an emotional trauma to a death, 3 is still closer to a low level of severity. There are over 50 of, or close to 50 number of claims which have been made for very low level of severity, which is about 3. Fewer numbers of claims are coming as we go up the level of severity. Interestingly, we would want to see whether this, as the severity is going up, is there a kind of a relation between this severity and the claim amounts which were also going up? Now, that's the kind of a thinking that I'm trying to pass it on today. Descriptive analysis is not just about plotting. Descriptive analysis is all about asking the right set of questions from the graphs, from the charts, from the matrix, from the variables that we are plotting. Similarly, we go next. We now want to look at how 2 of my variables would start to behave against each other. I'm just trying to figure out if I've left any univariate before I move on to the bivariate. Yeah, so I'll just quickly move on to the bivariate variables now. So if you look at now, what I have done here in the box plot is I have plotted the box plots for both females and males. And I wanted to see how the spread is. So if you look at very categorically, I can see the box is pretty thinner for males, very broad for females. If I would have been able to ask you this question, I would have asked, what does this interpret? But in practicality, we must understand these are greater inferences for us. We know the spread between the amounts claimed by males is not that widely spread, whereas in case of females, the amounts are widespread. So there is more skewness as far as, if we look at it from a perspective of females is concerned, there is outliers in the cases of males. So if you see, these black spots denote the outliers. So there are outliers more in case of males, but most of the amounts that they are claiming for, they lie very close to each other. So I'm just making this number, but maybe because of the numbers that are represented on the y-axis. So Q1 to Q3, which means 75% of their claims are for less than $100,000. Not even 100,000. In fact, it is much lesser, because 100,000 is, I would suggest, is here. So this is close to about a 50,000 or a $70,000. So where females have a 75% of the population claiming under $100,000, males are claiming 75% of the males are claiming less than $50,000, or maybe $60,000. That's the level of understanding that we derive when we compare the genders. So can we kind of create a hypothesis that are females or males, let's put it one way, are male claimants charging for higher amounts, something like this, or is it the female claimant which is charging for a higher amount? Now that's where we move from being descriptive to a diagnostic or a predictive stage. So that's the next level of analysis, and that's how we progressively move. Now, what if I want to see the gender amount along with the insurance? So if you look at the insurance categories, there are 5 of them: private, Medicare, unknown, no insurance, and workers' compensation. I want to, and the color coding is basically according to that. And this has been divided across males and females. Now, a very simple uproot of what we have done here is simply suggest that females largely have private and Medicares. But males, out of all the 5 of them, have primarily the private. So look at amount close to 200,000, and over and above that, they are making use of the private insurance, which basically means there is a possibility that there is some loophole that is being detected there. So this becomes even an interesting point. Dig in deeper into privately insured males data. There are chances you would find fraud. That's not a claim that we are making, that's a possibility. And that's how you kind of analyze using the descriptive analysis. That's what I'm trying to throw here is, think about in terms of wherever you find an anomaly in a graph or a chart as a possibility of exploration further. Now, this exploration is endless. The questions you can ask from the data will never end. But what is it that we are trying to look for is, we are trying to understand the data from all possible variables perspective. Now, the case has been trimmed accordingly for our discussions here, but there can be multiple number of variables. There can be large size of the data as well. Here we are only dealing with about 120 odd claim data points. So now what I've done here is, for reference purpose, plotted gender and amount for the 20 cases from the data. So if you look at how the amounts are being distributed, so if you look at it from a perspective of females, you would be able to see the numbers that are coming up, and for males you would see the amount that is coming up. Now, what does this female 426 500? These are on the basis of what you call as the higher amount of claims that have been charged for. Now, the bars here represent, looking at from the perspective of the amount that has been claimed. So don't just look at here, it's 1.6, it's the gap which is being represented by the number. So we see the dispersion in the claim amount for the top 20 females has around 426,500 also as the claim amount, 311,500 uh, also as the claim amount. Now that's the kind of variety, and as low we can see as 177,498. But in case of males, we see the amount has not even gone above 48,500 for the top claimants. So the highest that I can see is 48,500. So that clearly is giving me a picture that female claimants are asking for higher claim amounts. I haven't done any kind of further analysis, but this is giving me a clear picture from here. What else I can look at? I can also look at plotting this a little differently. You see this? Now that's a scatter plot. That's a little different way of plotting the same data. The idea is I see a big amount being claimed by female. So this is you see the color coding, which is as high as 102 as well, but this is somewhere in between, and a small dot and a small dot here. So you can see the dots for the male is hardly any visible. This is the 401 that we were talking about, the max that we can look at. It's the same thing. I mean, the representation here is clearer. That's another way of representing it. If there were more values, we would have seen a lot more bubbles in between. That's the idea. We can always plot a similar kind of a graph to depict similar analysis. But one thing is for sure, that gender is kind of playing a critical role. Let's start to look at insurance type. What is happening as far as the insurance type is concerned? So we see, irrespective of the gender, it's the private insured people who are claiming for the highest, where the highest amount has been clubbed up. So this is total. So for each claimant, we are looking at the amount, and we are adding that up based on out of the total how much is being divided by private, Medicare, unknown, no insurance, and workers' compensation. We would never have known that certain gynae-related problems are claiming for the highest number of claim amounts. You see that? Now, this is a clear-cut indication from the gender when we were looking at the top 20 female claim amounts, that it is very well connected to the physician which is coming from a gynae specialty. Is there a possibility that the gynae being represented here are the same, or they are coming from the same hospital, or they are coming from the similar kind of background of, let's say, the gynaes are connected to each other, something of that sort. So that kind of raises the concern. Then there is a family practice. You see that? Very clear-cut indication. Wherever we see a family practice as a specialty, it should raise our eyebrows. There's a possibility there might be higher claim amounts than there actually be. That's what the picture. So by far we know that amount is skewed, gender is playing a key role, the speciality is playing a key role as far as some special physicians are concerned as far as their specialty, and also severity at a lower level is there are more number of claims. At the higher level, the severity has been going lesser and lesser. So what I was saying is there's a parallel representation of these bars where we are interested in looking at the amounts. But if we want to look at the percentage of these claims made via the specialty in terms of overall pie, we see the 4 categories or 5 categories coming out predominantly the ones, which is the gynae, the family practice, the neurology, the general surgery, and the dermatology. So what are we getting as a picture by each step? By adding one variable to the other, we are kind of understanding that there are certain patterns with which we have to look at the claims. If you look at from the insurance perspective, that's the percentage. So we see 63%, close to 63% is about private. There are unknown 22% as well. That's a very, very high number if we are thinking from a perspective of fraudulent claims. From a specialty type, we have from the gender, we also can look at amount based on the severity type. So if we look at severity type 7 and 8 as an amount total, they take the majority of the pie. Very interestingly, which means that people with the severity level of 7 and 8 have claimed for the highest of the amounts. Although the number of claimants in with the severity of 7 and 8 is low, but the amount that they have claimed is very high, which means that people who are claiming for higher severity, higher amounts are to be looked in very closely. Now, wanted to ensure that I do not deal with the continuous variable on age, so I kind of bend it into the 10 labels, which is 1 till 9. So my entire age group is now divided into 1 to 9 group. And then we plotted what we call as an amount based on age. That's the amount based on age. So what we see here is people within the age group. So 5, so let me tell you the labels. This is from 0 to 10 years. 2 represents people up till 20, from 10 to 20. This is 20 to 30. So this is the age group which is between 40 to 50. Now, between 40 to 50 are the claims which are the maximum amounts. Means the total of the claims claimed by people in the age group between 40 and 50 is the highest, followed by people in the age group between 30 and 40. Gives us a kind of an indication. Yes, age also, when it comes for certain claims, has to be looked in very carefully. So people from 30 to 50, there are higher number of claims or higher amount of claims coming from here. That's the idea, or that's the picture we are generating using the age. And in percentage wise, we see this as close to about, if we put together, this is almost about a 70% of the population falls under the range of 30 to 50, and that's where they are claiming the highest amounts for. Now, I would have loved to go in deeper. I would have loved to talk about how age with amount with severity, how age with amount with gender, how age with amount with insurance type, how age with amount with speciality, when we know these variables are playing, can actually be analyzed. That's the next layer of analysis. I would have then loved to discuss about the hypothesis that we create. So is the hypothesis that insurance type unknown perhaps fall under the category of fraudulent claims? We can test that. Or unknown type private or unknown type insurance are generally being found with females, because we see higher amounts are being coming from females. Those kind of hypothesis is our next way of diagnosing the problem, or what we call developing a theory which kind of helps us create a storyline about what different parameters when put together will help me in identifying, or let's put it this way, help me in predicting finally that a claim that comes in into the system is a fraudulent or a non-fraudulent claim. First formal question here: would you do the outlier treatment first or missing information? Okay, outlier also belongs to the data set. So first of all, I need to find out whether I have the missing information or not, because missing information means that I would be making wrong judgments about the data where the data is not even there. So the first and the foremost piece after we upload from a scripting perspective, in processing, we do the missing value treatment. So it follows the order missing, and then we look at the outliers, or maybe digging into summarizing it even further. He's saying, when you say improving the process, can we correlate this with Six Sigma? And they're also calling as process improvement. Six Sigma is a very specific technique, again designed on top of statistics only. So at the back end of Six Sigma is hypothesis testing, which is nothing but the diagnostic and the predictive statistics piece of what I was referring to. So in a business world, the Six Sigma is the process improvement, but at behind the scene, what is working is the statistics. So it's actually the same thing. There is no difference, because Six Sigma also means process improvement, which means you first have to know your process, monitor it, understand the key features, then understand what features we can change and bring about those changes. Now, the question comes in is, how do we know those changes will bring an impact? That is hypothesis. And that is where we test it based on a sample. And then we finally conclude, yes, using certain variables of interest and changing the parameters, we can make the change in the process. Very simple, like defects in a particular manufacturing unit, which is very simple and straightforward application of Six Sigma. So we learn about the various defects rate. We then try to create a kind of a hypothesis based on a sample. We then try to see whether the sample fits the kind of hypothesis that we have proposed. Now, whether in the population that is happening or not is something will help us decide whether the claim is true or not about the defective process. That's exactly what we are talking to in terms of descriptive analysis, and you're absolutely right in saying that. Isn't KPI defined first and then we define hypothesis and analysis to check if we are meeting the KPI standards? Very interesting question, and that's why I distinguish the descriptive into two classes. Descriptive falls under two particular pieces. One is an exploratory piece, which is we don't know the KPIs. So we are digging in deeper to identify the KPIs. So what I did today was an exploratory kind of an analysis. And with the exploration, I was able to define the KPIs. Or I should call it, I was able to define the hypothesis. Once we have the hypothesis validated, yeah, we can then create KPIs for continuous process improvement, which is the performance monitoring. What I'm trying to say is, let's look at it this way in the context of medical malpractice. Right now, with the sample, we identified that the specialty of the physician kind of is playing some role in the higher claim amounts. So should I now test the hypothesis or directly create a performance improvement or a KPI saying whenever I find a specialty of gynae, I must analyze it thoroughly? What we should do first we should test this hypothesis. And then once the hypothesis is, let's say, validated, we then make it a performance indicator. I hope that order is clear, because until and unless the hypothesis is validated, we don't create KPIs, at least from an exploratory perspective. Now, otherwise, there are certain processes, as I mentioned, in a finance process. I know a PR should always precede a PO, right? A PO must be connected to an invoice. Now, there is no if and but into it. There are no hypotheses to be generated here. These are factual situations. Now I can directly create KPIs. KPIs like, I want to test in my ERP system how many POs exist in my systems which have a date earlier to the date of a PR. Exceptions. I can directly define my KPIs in those scenarios. All depends on whether we are doing an exploratory kind of study or we are doing a study wherein we already have insights into this process. That's the difference. When you're mentioning standardization, are you meaning making different columns of data values come under a similar range of values? I'm not saying that. What we are trying to say standardization is not just one, let's say, okay, standardization term comes from databases primarily. And when we are talking about standardization, we are talking about if somebody is, let's say from a banking perspective, I'll give you an example in that because there the standardization is very high. From a banking perspective, if we are supposed to collect certain specific demographic data from the customer, the data must be stored in the database in the same format. Doesn't matter whether that format or whether that database is to be used further by the customer team, or to be used by the finance team, or to be used by the front end team, or to be used by the product team. Standardization of the data means, what I was referring to is, you have the columns defined to be used pretty much the same way by all the stakeholders. In one way, what you're saying is units values are concerned. Yeah, so the unit is predefined, but that unit doesn't change when we change the stakeholders or when we change the user. It remains the same. But one column has nothing to do with the other column. So they are inclusive from that perspective. I hope I got your question correctly otherwise. How to decide KPI metrics using the analysis. If it is with respect to just variables, how to know what variables need to be looked at. That's Soma, that's the question that you understand by discussing with the business team. So business people are the ones who are going to suggest that these are key indicators that we kind of analyze, or these are the key variables that we study. Now you bring in the lens of an analytical perspective. You think from the analytics that every variable is important. That's why what I showed you today is you do not leave out the variable simply on the basis of your biasness of the analysis. You analyze each and every variable from first from univariate perspective, then from bivariate, then from multivariate perspective. You would then know which variables we should consider for further analysis. How do we identify what data points are to be collected, identified for a particular? I think it's very similar, which I handled above. About medical practitioner who treated the patient. Yeah, so Puram, that's exactly what the specialty of the doctor we are referring to. Now, once we know that we have identified specialty as a major concern, we can then dig deeper into finding out individuals or the doctors that are kind of referring to. Now, do you have any minimum threshold on the number of variables in the data set? Anu, no. The answer is no. If you can analyze it one variable, why would you not? But yeah, minimum should not be less than one. That's the fair. The question on features is very similar, and I would again reiterate the fact that when we are dealing with multiple features, the objective and the, the approach is to go by each and every variable, to dig in deeper into understanding the relation of uh, most critical variable with all other variables. Like in our case, we can very clearly say that the claim amount is the most critical variable that we have to analyze, because that's where the losses and the gains can be referred back to. But what other features going to play a role in predicting the amount is something that is always unknown. And that's where we make use of the exploratory study. And that's why I said if the study is exploratory, we would have to do a very fundamental way of analyzing it the way that I did it today. Otherwise, if we have a background, we select it using multiple ways. Now, since you're doing data science and machine learning would be one of the aspects, I must tell you that nowadays there are very, very powerful feature engineering algos, which helps us identifying key variables and their impact on the target variable. But statistically and machine learning ways, they exist. And well, I should say they are beyond the scope of today's session, but yeah, they exist. Is this data actually extracted from an insurance company, or it is just for demo purpose? This is a snapshot of a case that we kind of prepared, which is like what you say, a white paper that we produced, wherein the snapshot of the data is from the actual company. Yes. Now, while collecting data, do we have to choose the relevant data? How to choose the relevant data? That's again the point. How we go about in terms of identifying the right features. So we start with whatever is available to us. But when we reach to a level that we can recommend to the organizations as to there are certain other variables that you can collate, that stage comes under once we have done the preliminary analysis. So initially, we work with the data in hand, and largely companies have huge amount of data. So there is no dearth of features. Problem is to select those features. What is an unknown insurance company which is significantly large? Yeah. So unknown insurance company primarily in the from the US context, it meant that there are certain sources of insurance companies which were unknown while at the time of the claim was made. So maybe it came via a private attorney, maybe it came via a legal channel, maybe there were certain exceptions which were made. So the unknown category was given to those claims where the type of insurance was not given by the claimant. What would be the approach if the variables have a mathematical relation? When you say mathematical relation, I'm assuming you're saying there exists some kind of correlation between the variables, or there are some linear combinations of each other. There are different approaches to handle those kind of questions, Anu. We kind of test for multicollinearity, statistically speaking. We either consider features which are of higher importance than the others, playing more important role than the other. Again, statistically can be tested. So there are ways how we detect that. Saurabh, if you're asking from a standpoint of framing the hypothesis first or doing the exploratory first, I would always suggest go with an unbiased mind, go without setting up any hypothesis, explore the data, let the data speak for itself, and then create the processing a part of EDA. Yes, it's a part of the EDA. Is the assumption that higher claim amount may indicate fraud? Since we don't have a fraudulent indicator in past to understand the data, we are making that as an assumption. In the case, we are making that as an assumption. If we do the imputing of missing data, will we not be imputing with an incorrect mean due to the outlier? Uh, I don't remember saying mean as the way of imputation. Imputation can be done in several ways. So we will have to identify and do a further outlier analysis to find out which way of imputation would work best in this case. Hope that answered that question. Uh, how to deal with missing values in a categorical variable, what could be the implications. The question is statistically have been handled multiple times. If we don't know certain things about categorical variables, we either have to assume a kind of an average, if largely available. Average doesn't have to be mean, rest assured. When I say average, I can refer to median mode as well. So let's understand, even if it's a categorical variable, the average can be found. But if there is a way to identify the value of the missing value of the categorical variable using the other variables, we try to use that approach as well. If not, the last or the best case resort is delete the row items. Now, when it comes to descriptive analysis, we are plotting the graphs and using statistics measures, gaining the insights. What about diagnostic? What kind of technical work we do to find the root cause? See, one of the examples of diagnostic vector detection was something that Six Sigma is one of the approaches which is all about diagnostic. There are other ways of diagnostics as well. So your simple uh, regression techniques, your simple correlation techniques, your simple techniques on uh, cluster, which is not cluster from a machine learning perspective, but cluster from a statistics perspective, although they are related, but that gives us kind of diagnostic view. Then under a lot of, let's say, operations techniques, there are ways of identifying the root cause. So I am not sure if you have heard of something called as a fishbone or Ishikawa diagram, which is primarily used for identifying the root cause analysis. Those kind of analysis can be performed. We can speak about the essential tools that we use in practice. We use a lot of tools in practice. For EDA, we make use of both scripting and visualization tools. Because of visualization, I think it's very interesting because we are able to then narrow down our analysis moving further from there. So tools, as I mentioned, are Python. These are scripting tools, but nowadays there are a lot many tools which do not require you to script. So tools like Rapid Miner, tools like Alteryx, tools like Data IKU, tools like 9H2O. These are tools without the scripting knowledge. You can just do what you call pull and draft the kind of models, and they will give you the ED. Visualization, I always prefer Tableau Power BI because there is no other better tool than that in the market.
Now, when finalizing the variables to be included in the analysis, should we follow the business perspective and the statistics perspective? Okay, the question is from the side of how to decide the features based on business or based on statistics. See, this is where you would have to come and play your role. When I say come and play your role is you would always be working with business stakeholders. So they would have business understanding. Take them as an input. Bring your insight from a statistical perspective. Do not assume that the business knows everything, and do not assume that you bring in the variables they will not contribute. So an unbiased approach is to bring in all features and then try to cut them out rather than not including them at the front. Basically go with what stats math is giving us for what business suggests there could be difference in the two cases. Correct. So that's what the idea is. We must go by both the approaches. We must include most of the variables, try to reject and try to delete variables rather than not including them in the study. What is the percentage allowed for missing values? There is no percentage allowed for missing values, Deepak. We should try to impute almost all the missing values in the data depending on the size of the data that we are dealing with. Why I'm saying this, if we are dealing with a critical scenario where the data size is small, not even a percentage would be acceptable for missing values. And when we are dealing with data where the numbers are large, we can still figure out and deal with some 2 to 5% of the data which is missing and deal with it. What model do you use to build the fraud prevention model? There are multiple of them, Sarovar, out of the scope for this session. But in machine learning environment, there are multiple machine learning algos these days which are very well applicable. From a perspective of what I have done personally, I have made use of decision trees as well, from a card to the you can say the random forest as well. But primarily the models which have shown a kind of greater output has been the neural nets. Yeah, but they are still evolving. So there is nothing concretized in the market right now. So anyways, is there any specific validation measure, correctness of analysis performed on the data? As far as validation on the let's say on the descriptive side is concerned, the summary itself is the validation. So summary of the data tells us are we dealing with the right data set or whether the business supports the fact that whatever the summary is saying is supported by business backing or a business claim that yes, this is correct. There is no specific validation measure there. Can we change our samples few times to see if there is a change in a description? Correct. We must do that, Abhishek. If we have extra time, can we show an example of itosis? Sangeeta, sorry about that. I've done 2 and multivariate analysis. I tried doing that. I'm so happy about the fact that you guys are thinking the next step, but I apologize for the time under consideration we had to restrict.
This brings us to the end of this tutorial on advanced statistics. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. Thank you very much for attending this session and have a great learning ahead.